If you've been watching Dream's Minecraft Manhunt series, you've probably seen this video, Minecraft Speedrunner vs 4 Hunters the Rematch, where he somehow overcomes an almost insurmountable challenge, 4 Hunters with Protection 4 iron armor.
How are you not dead? What? I've crit you like 6 times!
The way he does this is by escaping into the nether, teleporting up on top of the nether, building a second portal and returning into the overworld at a new location, luring the hunters into the portal, leading them far away from this portal before purling back, lighting TNT at the portal, and escaping just before the portal blows up. Trapping the 4 hunters in the nether with no choice but to kill each other, respawn, and start from square one. The editing in this scene, combined with the creativity and skill required to pull this stunt off, has to make this one of the most impressive plays in any of the Minecraft Manhunt videos. As incredible as this whole thing is, though, one thing in particular surprised me. The way Dream threw those ender pearls seemed wasteful, like he wasn't throwing them as far as he could be. That said, he was still traveling pretty quickly, and I wasn't going to assume Dream was doing it wrong because, well, he's Dream, he knows what he's doing. But I still didn't really know what was going on. This got me thinking, is there an optimal angle to throw ender pearls? How much does it really matter? So I did some math, I did some testing, and today I want to show you what I found. So if you're just looking for the answer, 40 to 45 degrees gives the best distance, while 4 to 6 degrees gives the fastest travel speed. But it's a little more complicated than that. We should start by understanding how ender pearls travel. Minecraft physics are pretty simplistic. For starters, gravity is constant, and as far as I can tell, there's no real wind resistance. This means that when we throw an ender pearl, the horizontal speed is constant. If the x value is changing 25 blocks per second when we throw the pearl, the x value will still be changing 25 blocks per second when the pearl hits the ground. Now, for example, if we know the pearl takes 2 seconds to reach the ground, the total horizontal distance traveled will be 25 blocks per second times 2 seconds, or 50 blocks total, right? Because if you move 25 blocks every second, after 2 seconds you will have traveled 50 blocks. So if you can somehow take the angle and calculate the horizontal speed and the total flight time, you could figure out for any angle how far the pearl should travel. This is where we use something called trigonometry. All you need to know is that these two math functions, sine and cosine, can tell you a lot of information. For example, in this picture, if you know the diagonal line is 5 blocks long, and the angle at the bottom is 30 degrees, then you can use these equations to figure out how long the other two sides are. What's cool about this is that we can also use these equations to find the horizontal and vertical speed. Maybe we're going 5 blocks per second, so we can just use the same equations. It's a bit more complicated than that, and I encourage anybody interested to watch some more videos on trigonometry, which I'll link in the description, but all you need to know is we need to find the maximum possible value of this equation. Sine of the angle times cosine of the angle. It turns out this value is maximized at exactly 45 degrees. So if we throw the pearl at 45 degrees, theoretically, we'll maximize the distance our pearl goes. Now, it's important to test your theories, because what good are theories if they don't work? I manually tested ender pearl throws at a bunch of different angles. This took a little while to do, but in the end I was able to get some pretty consistent data. Like we predicted, the sweet spot is around 40 to 45 degrees. Oh, and here's the exact data if you're interested. However, this still didn't answer my original question. Why was Dream throwing those pearls at such a weird angle? Well, Dream wasn't just trying to throw the pearl as far as possible. He was trying to go as fast as possible, and if he lobbed the pearl way up in the air, it might go farther, but it would take even longer to come back to the ground. So by throwing the pearls low to the ground, each pearl still goes pretty far if you remember from this picture, but they hit the ground much faster. Now, the math involved here is a little weird, and honestly I don't know how accurate it would be, but here's the general idea. For every angle you know how far the pearl goes and how long it takes to get there. You want to maximize this ratio. In other words, you want each pearl to go far, but you also want to be able to rapid fire them. Instead of mathematically solving this, I decided to just do some more testing and gather some more numbers. Here are those numbers. You have the angle and the distance data I collected earlier, but this time I went back and measured frame by frame how long each pearl throw took. And if you're wondering, yes, this was super tedious. Anyway, since I had the travel distance and the travel time, I could just divide distance by time to get the speed in blocks per second. Believe it or not, an angle of less than 10 degrees seems to give the fastest speed. And if you look at the Minecraft Manhunt videos or at other videos of Dream, they all seem to have a similar angle. So as far as I can tell, this is actually pretty close to the optimal angle for throwing ender pearls. In fact, I would guess Dream has gone out of his way to test this, maybe not super rigorously, but at least enough to come to a similar conclusion. And I think that's pretty cool. This is my first video, and I'm planning to upload many more. I'd really appreciate it if you considered liking this video, and if you want to see more, then you might want to consider subscribing. That's all I have for this video. Thanks for watching.